In this video, we're going to simplify an expression that has a negative inside the square root. Now, the simple first instinct that some students have is to recognize that 8 goes into all of these numbers, and students begin to cancel and cancel and cancel or reduce and those kind of things. That's not what we do in this problem. Part of the issue is that the 32 is inside a square root. In addition to that, it's a negative 32, so we need to process the negative properly. So as we saw earlier, let's talk about that negative inside the square root first. So to help us simplify a radical, we can write the numbers inside the radical as a product of two different numbers, and negative 32 is the same as negative 1 times 32. And then the rules of radicals allow us to split those up into two separate radicals, the square root of negative 1 times the square root of 32. In previous videos, we've learned that the square root of negative 1 is what we refer to as I. So we can rewrite the square root of negative 32 as I square root of 32, with the 32 being positive now. Okay, now, even though we've processed the negative, we still can't reduce these numbers. 8 does go into 24, and we will simplify that eventually. But for now, we need to work on reducing the square root of 32. Now, some of you may know how to do that. If so, you can jump forward in the video now. For those that don't recall how to simplify the square root of 32, the process we want to use is try to find a number that's a perfect square that goes into 32. So let me make a list of perfect squares. So now I have a list of perfect squares. And let's look for the biggest one that goes into 32. So 4 goes into 32, so maybe that's my biggest one. Let's try some other numbers. 9 does not go into 32, but 16 goes into 32. And if we keep checking after that, 25 of course won't go into 32, and then 36 is larger than 32. So 32 is divisible by 16. So we're going to use the same trick we used up here. We're going to call this the square root of 16 times, and 16 goes into 32 2 times. So square root of 32 is the same as the square root of 16 times 2, and we can simplify that into two radicals, calling it square root of 16 and the square root of 2. And now square root of 16 is 4, and square root of 2 is what's left. So the square root of 32 is fully equivalent to the number 4 times the square root of 2. So now let's rewrite this expression. So you see I've incorporated the 4, I put it here in front of the I, and then I changed the square root of 32 to the square root of 2. So I used 4 here and the square root of 2 here. Now we can simplify from this point. If we look at the numbers that are outside of the radical, we can work with those numbers to try to simplify them. So look at these three numbers and decide what goes into those three numbers. And hopefully you see that 4 goes into those numbers. So now we can write negative 2 plus 1i, or just I, square root of 2 over 6. And again, it may be tempting to try to recognize that, oh, 2 goes into all these numbers, but since that 2 is inside the radical, we cannot separate it out as far as simplification. And in some cases, your instructor or your homework may require you to separate this into the real and imaginary parts. So let me take that step, and I'm going to put negative 2 over 6. We take the negative 2 over the 6, and then write plus, and now I'm going to take all of this over the 6. So I square root of 2 over 6. If we do that, in this case, you do need to simplify, and you can simplify negative 2/6 to become negative 1/3 plus. And then our typical method of writing the imaginary part is to put the coefficient first and then put the I afterwards. Both of these are fully equivalent in the way they're written. And again, the square root of 2 over 6 cannot be simplified, but this does demonstrate that 2 over 6 can be simplified. So hopefully it's clear what can be simplified and when and where. And that is our final answer.